All right, morning everybody. Nice Friday morning, nice and wet outside. How's everybody doing? Hopefully you guys had a good night's sleep and are ready to get going. If you're not here, if you're just gonna watch this later, that's absolutely fine. I actually I highly recommend, if you haven't gone through the review yet, that you wait and you go through the review, solve this all on your own before you watch this. Rather than watch this live, it's better to do that. And so if there's anybody like that that hasn't gone through the review and has any questions, you can go ahead and ask those right here at the beginning. And then you can log out or just close it up and then come back here later and watch the video later. All right? So let's see. Any questions? How's everybody doing? Doing well? Hopefully. I will say before we go over any of this that your test will look a lot like the last test. It's not going to have any of this multiple choice kind of stuff on it. I just wanted to go over the multiple choice anyway, just because I thought it would be interesting. But that's about it. You're not going to have multiple choice on your test. It's going to be all free response, probably about maybe 4 questions, just like your last one. 4 questions, free response, similar to these questions that you guys have here in the review. You got 5 questions in this review, but I think you'll probably only have 4 on your actual test. Okay, so just like last time, same kind of format, same kind of rules and all that kind of stuff. It's going to be open notes. Obviously, you're going to want to have a calculator, and you may not talk to anybody about it. You may not ask for help or give information to anyone, right? But otherwise, you may use whatever references you need, book, notes, even the review, whatever you need. Okay? All right. So free response number 2. Did we do a problem like that? Yeah, you did. It's got a little bit of a different wording than some of the problems in the book, so that might be what might be bugging you. But yeah, it's a lot like some of the stuff we did for Hooke's Law, which I believe was the first day. Yeah, I believe the first day of this chapter. But we'll go over it. A little bit of a different wording because it talks about, yeah, just a little different wording. That's it. Okay? Any other questions? Every question here is definitely applicable to what might be on the test. And, all right. Let's just start off with the multiple choice and then jump into the free response after that, okay? Let's see. And we will start. Oh, here we got another question. K is always positive. Yes, K is always positive, and the force and the displacement for that spring are always going to be opposite. So one's going to be positive and the other's going to be negative. So K is always going to be positive. Yep. So just copy the review sheet model. Yeah. Yeah. Again, the wording is going to be different numbers, different kinds of like wording and all that, but the same idea, right? Just like your homework. This is really all related to your homework. Very, very similar. Same equations. I would, especially when you go into a test like this, open notes, I know that you have the ability to look back at your notes and all that stuff, but I would take the time and rewrite the equations that you're going to need. Right? I think there's only about 4 of them, and so rewrite those on a sheet of paper so that while you're taking the test, you can just quickly look at that sheet of paper with the equations. That would probably be a good idea, and it could save you a lot of time, right? Remember, the test is timed, and you don't want to spend 15 minutes just looking through your notes trying to find an equation. Okay? All right, so let's get started. On the multiple choice, we've got vibration of an object at an equilibrium point is called simple harmonic motion when the restoring force is proportional to blank. Now, I'm not going to say this is not very important in my opinion, but it's just got to do with the definition, and I didn't even talk about it. It's in your book. It's got to do with the definition of simple harmonic motion, so it's got to be the restoring force is proportional to the displacement. All right. Let's make that a different color. Here we go. Displacement. All right. And that's basically just the definition of simple harmonic motion. When you have a linear relationship between the displacement and the restoring force. Okay. Number 2. A simple pendulum swings in simple harmonic motion at maximum displacement. Now, this is going to be a little bit more important than number one, in my opinion. So at maximum displacement, well, what's going on? We spent some time thinking about this. When the displacement is maximum, that it means, let's even just write it all out. That means the velocity is going to be 0. The force is going to be maximum. And if the force is maximum, that means the acceleration is going to be maximum. And let's see which one of these fits here. It says acceleration reaches a maximum. Yeah, that's going to be right. Okay, but let's check the other ones too. Velocity reaches a maximum, no, velocity is 0. Acceleration reaches 0, no, acceleration is max. Restoring force reaches 0, no, that's max. So, yep, 2 is going to be A. All right. Okay. So question. So somebody said B. Is that was for number 1, right? I think so. Anyway, if there are any questions, just stop me here. A mass spring system can oscillate with simple harmonic motion because a compressed or stretched spring has which kind of energy? Now, it does have mechanical energy, but that's not really answering the question. All right, so the question is, what's actually causing this whole simple harmonic motion? And it's going to be that elastic potential energy, the potential energy that's stored in the spring, right? That's what's causing it to be able to work. Number 4, for a mass hanging from a spring, the maximum displacement the spring is stretched or compressed from its equilibrium point is the system's. And again, this is not something that we really talked about. It's in your book. The answer is going to be amplitude. Okay, so and you can think about any kind of wave has an amplitude. That's going to be that maximum displacement point. All right, just a kind of another way of thinking about what amplitude is. All right, amplitude for these systems is basically the distance from, if you're talking about a pendulum, because that's a little bit easier to think about. If you're talking about a pendulum, it's from the equilibrium point to that maximum point, right? If it's for a spring, right, it's going to be, once again, from that equilibrium point to that maximum point, whatever that is. Okay, so it's not, for a pendulum, it's not going to be the back and forth. It's just going to be the amplitude is from the equilibrium point to the maximum point. That's your amplitude. And that can be an angle or it could be a distance, whatever is more appropriate for the equations that you're using. All right, number 5, how are frequency and period related? And we mentioned that, definitely very important. And you're going to need to know this for the free response, okay? So frequency and period are inversely related. And so T equals 1 over F, or F equals 1 over T. Inversely related. All right, so that is the multiple choice. Any questions on that? Questions? Anything at all? All right. So we'll just start the free response then, and you guys can ask me questions as they pop up. Free response, so just be thinking about those different equations. When you've got, so in this one, you've got a force stretching a spring, and you want to know the spring constant, right? So make sure you have a list of all the equations that you need. This equation that you're going to need is Hooke's law, so force equals negative kx. And make sure not only that you have the equations, but you also know what the different things mean in the equation. And you can even label them for yourself if you want, right? So that's going to be your force, that's going to be your spring constant, and that's going to be your displacement, or the amount that it's stretched or compressed. So let's go ahead and identify things. So this is your force, this is your displacement, and so we want to calculate the spring constant. So we're going to calculate K. Okay, so rearranging that, divide both sides by x. That's going to get us a negative F over x equals K. So I can plug in some numbers here. Negative F, that's going to be negative 25 over a, so if the force is positive, that means that your x has to be negative. So this is going to be a negative value for x, negative 0.36 meters. Because the two are always going in opposite directions, one of them has to be negative. And so that's really the point of what this negative is right here. Your k must always be positive. Okay? K must always be positive. So the negative over negative are going to cancel out. And that's going to give us simply a 25 divided by 0.36. And that's our answer. That's K, 69.4. 69.4. And units, so F, force is in newtons, and X is in meters, so this is in newtons per meter. Okay? All right. Questions on any of that? All right. Let's go on to the next one in the back. I think I got it underneath here. Yep. All right. So on the back, we've got number 2, which is you got a 0.53 kilogram mass suspended from a spring. So now we still have a spring, but we have simple harmonic motion. And here we go. So the simple harmonic motion equation, again, one that you guys are going to want to have written down somewhere. Oh, no, but although it's in simple harmonic motion, it's actually not asking us about the period or the frequency. It's saying this, right? At the instant the mass is displaced from equilibrium by a certain amount, what's its acceleration? So nice problem here for number 2. A little bit of a different wording here. So what's going on? We have a displacement and we have a spring constant. We want to know what the acceleration is. And in the back of our minds right now, we should be thinking acceleration, right? Well, how in the world are we going to get that, right? F equals ma. So that's an equation that we should all know by heart, right? F equals ma. The force is the mass times acceleration. So we can get a force from Hooke's law once again. So F equals negative kx, because we have an x and we have a k, we can calculate the force, and then we can calculate the acceleration this way because we also have a mass. So that's the kind of thing that we should be thinking about. It would be tempting to put this into the harmonic motion equation because it tells us that this is in harmonic motion, and we're thinking that whole thing with t equals 2 pi square root of m over k, but that's not going to get us anywhere, right? It's asking what the acceleration is. So the wording can be tricky, but the equation is fairly simple. So let's solve this one first, then we're going to solve this equation next. So we want it right away to just jump in and solve for the force itself, okay? So we have your force equals negative k is, all right, spring constant is 31.8 newtons per meter. And we have a displacement of negative 0.105 meters. That's going to get us our force. And you could put this and combine these to make one big equation. I'm not going to bother. I'm just going to calculate the force first. Okay? So we got 30. And negative times negative is positive. And so I don't need to put the negatives in my calculator. All right, 31.8 times 0.105 gets me 3.339. 3.339 newtons, right? Newton meters, or newtons per meter times meters is going to simply get me a force in newtons. All right? And remember, a newton is a kilogram meter per second squared. Okay? So that's our force, which we're going to plug into this equation. And this equation we want to rearrange to solve for acceleration. Remember, our whole goal here is to say, what is the acceleration? Figure out the acceleration. So divide both sides by m, and that's going to get me an acceleration is force divided by mass. And so we know the force now is 3.339 newtons. And our mass way back at the beginning of the problem says it's 0.53 kilograms. Be sure to check out your units, and our units here are fine, right? Newtons are your standard units, kilograms are the standard units. So the units are fine, but make sure that they are, because sometimes you might be in grams or something else. Okay, so I just divide my previous answer by 0.53. That gets me the acceleration is 6.3. Oh, that's kind of a nice that turned out to be such a nice number. Okay, 6.3. And the units for acceleration are what? A little tricky here because it's newtons divided by kilograms, but if you remember that a newton is a kilogram meter per second squared, or if you just simply remember what acceleration unit should be, it's going to be meters per second squared. Okay? So that's number 2. That one may have been the problem to give you guys the most trouble simply because the wording is strange and you have 2 separate equations that you need to use to actually solve for your answer. So that may have been a bit tricky for you guys, but hopefully you guys got it. And if not, if you have any questions, you can ask me now. Otherwise, we're going to jump down to number 3. We have springs once again. A mass and a spring vibrating in simple harmonic motion with an amplitude. Now we do have that actual simple harmonic equation that we're going to be using. And if the mass of the object is that and the spring constant is that, what's the frequency? So this also has a little bit of a tricky aspect to it, but you have to remember, all right, the question's asking for the frequency. And so we know that the frequency is related to the period, right? The frequency is 1 over the period. And we know an equation for period, right? You know the equation for period is your 2 pi square root of m over k. So this is, and look, notice that I'm writing down all the equations you guys should know in red here so that you point them out. Make sure you have those things written down so you guys know the equations, okay? So here we go. This is our equation for a spring vibrating and the period of that, okay? What is tricky here is the extra information and the fact that you're not solving for period, but you're solving for frequency. So once again, we have 2 equations, and there's something that's not going to be put in here. I know sometimes you guys like to use all the numbers, but here you're not going to. And the number that you're not going to use is the amplitude, because amplitude is not part of that whatsoever. The period doesn't actually depend on the amplitude at all. All right? So it just depends on the mass and the spring constant, and so let's solve for that. So we have, just plugging in numbers, that's going to get me 2 pi times the square root of the mass. Where's the mass? 0.65 kg. And the spring constant is 210 newtons per meter. All right? And I'll just plug that in. That's going to get me 2 pi times the square root of 0.65 divided by 210, and that's what we get. 0.3 is about 0.35, or yeah, we'll just, for right now, just put 0.35. And our units for period are seconds. But I'm just going to leave that number in my calculator and use it right away because I need to not calculate the period, but calculate the frequency. It asks us for the frequency. So right away, for my frequency, I'm just going to say, okay, it's going to be 1 divided by that 0.35 seconds. But to avoid any kind of rounding errors, I'm going to use the number directly in my calculator, touch one single button to get the answer, and that's this button right here, x to the minus 1, all right? And that's going to be essentially 1 divided by that number, give me the inverse of that, hit enter, and there it is. That's my final answer, 2.86. 2.86. And the units are inverse seconds, or more appropriately, hertz. So 2.86 hertz. Okay? 2.86 hertz. Questions? All right. We got a couple more problems to go. Thankfully, these other problems involve only single equations. Number 4. This was the problem that I was hoping to get on the homework, but we never got. A problem where you go into another planet, right? And you have to figure out what that acceleration on the other planet is. So it's pretty cool. But I don't know what your test, well, maybe I do, maybe I don't. I don't know exactly what your test is going to look like. Maybe you're going to get a problem solving for the acceleration, maybe not. You could literally solve for any one of these variables. So let's see, what's the equation? We have a pendulum swinging back and forth. Our pendulum equation is, once again, it's going to be a t equals something, right? It's for the period, is 2 pi square root of L over a sub g. Okay, this is not two different things. This a sub g is the acceleration due to gravity. Please make sure you keep that in mind, right? Rather than thinking, if you thought that's an acceleration and that g is something else, that would get you into real trouble. This a sub g, there we go. All right, I think we're back. I think we had a brief technology glitch or something like that. All right, so we're back. So here's the equation that we're solving for, and we need to actually solve for the acceleration due to gravity. So it's going to be a bit of a pain to rearrange, but we've done something like this before, so not really that bad. All right, so the first thing, so step by step, we're going to first divide both sides by 2 pi, so we get this all by itself, this whole square root term. So that's going to be t divided by 2 pi equals the square root of L over a sub g. Now we're going to square both sides to get rid of the square root. That's going to be t squared over 4 pi squared equals L over a sub g. Now what I want is in the denominator, so to get it up in the numerator, I'm going to cross multiply. It's the easiest way, in my opinion, to do it, but there are many other ways to do it. So that's going to get me t squared a sub g equals 4 pi squared L. Finally, I'm going to divide both sides by t squared to get me the equation that I want. A sub g equals 4 pi squared L over t squared. All right, and that's my equation. And I mean, I hate to say it, but you don't actually need to be able to do this rearranging on the test because, again, it's open notes. So if you do all this rearranging, if you've taken good notes, in your homework, the homework combined with the review, we've literally probably done every possible rearranging of this equation. So all you need to do is look back and check, okay, is this rearranged correctly? So that's a little bit one of the things that I find to be unfortunate about this open note stuff, but whatever, it is what it is. So the prepared student has a huge advantage. If you've done the homework and you got all these good notes, then you're good to go, right? So let's plug in the numbers. That's going to give us 4 pi squared, your L here, right? How long is it? It's 2.88 meters long, and it has a period of 1.85 seconds, and we need to square that, which is 4 pi squared times 2.88 divided by 1.85 squared. All right, hit enter. That's our answer, 33.2. And what are the units? We can look back over here. We got meters on top, second squared on the bottom. Or we can just think back and say, okay, this is acceleration. What should the units be for acceleration? And we're thinking meters per second squared. Okay? So that is a pretty strong acceleration, probably a planet that we don't really necessarily want to go to because it would be difficult to do things. It's a little bit more than 3 times. It's about almost 3.5 times the acceleration due to gravity here on Earth, which, might make it a little bit unpleasant. Having a smaller gravity would be easy. Having a larger gravity than we have here on Earth could be a challenge. I don't know. I've never been on a high gravity planet. Last of all, so we got somebody giving us the question number 5. And yes, that is the first part. Well, actually, no, that's not the first part. It's almost the first part. So giga, if you guys, again, you guys can have a chart to reference, but if you remember what the different prefixes are, right? So kilo is, what's that? That's 10 to the 3rd. Mega is million, or 10 to the 6th. And giga is going to be 10 to the 9th, right? And tera is 10, oops, did I write that wrong? 10 to the 9th, and tera is 10 to the 12th. So giga is 10 to the 9th. And so these are the prefixes that, you know, it's been a long time since we've talked about them, but you guys should be familiar with. And they're used all the time for technology, right? You talk about kilobytes, megabytes. It's important in information and also in your pictures and stuff, right? So megapixels, right? And then you have gigabytes. Everything nowadays is in gigabytes. In 10 years, we're going to be talking about terabytes. But yeah, so that's your information thing. So giga is 10 to the 9th. So your frequency, microwave ovens have a frequency of this. So your frequency is 2.5 times 10 to the 9th hertz. And you need to make sure it's in scientific notation before you actually do the calculation. So your equation is what? Your equation, now you have 2 different ways you could write this equation. Your equation is, and unfortunately I've done everything there in red too, but whatever. Your equation is the speed of a wave is going to be the frequency of the wave times the wavelength. Or specifically, you should be familiar with microwave ovens, that they are a type of electromagnetic radiation. And so we're talking about the speed of light. So C equals F lambda. All right? And I will try to make that clear on the test. I'm not just going to expect you guys to necessarily know that, okay, microwave ovens, we're talking about photons, we're talking about electromagnetic radiation. But this is a form of light, okay? So we're going to use the speed of light is the frequency times that, and then now we can rearrange it fairly easily. So if we're solving for the frequency, the wavelength, what's the wavelength? We're going to solve for lambda, so divide both sides by the frequency. That's going to get us C over F is lambda, or, and you can look this up, or you should, I mean, it's one of the few constants that you really should know, but of course you can look it up. The speed of light, or C, is 3 times 10 to the 8th meters per second, or like 2.999 or something like that, or 2.99 something, 2.998, depending on exactly on what you're in, but 3 times 10 to the 8th is close enough. Divided by the frequency, which is 2.5 times 10 to the 9th hertz. Hertz are inverse seconds. Okay, so meters per second, the per second over per second are going to cancel out, and your answer should be in meters. So let's do this. The way you put this in your calculator is very important, or you don't even have to, what you can do, if you know how to do exponential math, you can realize that 10 to the 8th divided by 10 to the 9th, when you divide, you subtract the exponents. So 10 to the 8th divided by 10 to the 9th is 10 to the negative 1. Okay? So what you could do, legitimately, if you want to be careful and you know how to do exponents, you could do 3 divided by 2.5, and it's going to be that number times 10 to the minus 1, move the decimal point 1 spot to the left, and the answer is 0.12. Okay? Or probably what I would recommend you guys doing is just type it in like this, but you have to be careful in terms of how you type it in. If you use the E, no parentheses are necessary. So it's going to be 3E8 divided by 2.5 E9, enter. That's it. That's your final answer. Okay? And I mentioned this before about the whole parentheses issue. I'm going to go ahead and write down my answer first because I know that's right. 0.12 units are meters, right? Meters per second over per second works out to be just meters, and that makes sense because we're talking about a wavelength, okay? But let me just, before we close out here, mention about what you should not do, okay? Let's suppose you're doing 3 times, where is it? 10 to the 8th, all right? And then you say divided by 2.5 times 10 to the 9th. This will get you the wrong answer. Let me just show you. That's totally wrong. Why? Because the calculator divides by 2.5 and takes the answer of that and multiplies it by 10 to the 9th. I get this. Somebody always does this. So please, hopefully, if that's you that's about to do this on your test, hopefully you're watching and you don't do this. So there's 2 fixes. You could either put the whole denominator in parentheses, and that'll fix it for you, okay? Or just do it the easiest way. 3 second E 8 divided by 2.5 E 9. Now I know different calculators are different, and so you have to be careful about how your calculator does stuff, right? A calculator is a tool, but it's not going to do the problem for you. So make sure that you think through and figure out, and you should have done like several of these in your homework and right here beforehand, so you know, or you should know how to use your calculator. So make sure you go into the test knowing how to use the tools that you use. All right? So that's it. Any questions about the test? We're going to have a test first thing on Monday. All right, so be ready, be awake, be there on time. So go there first thing on Monday morning. Okay? What's that? 7:45. We're going to start right away. I may even, I'm probably even going to upload the test early, so it'll be up by 7:40. Okay, so give you guys plenty of time. So 7:40, and we're going to end at 8:30 or so. Okay, so make sure you have that test ready to go, so you have plenty of time to do it. I'm giving you guys an extra 5 minutes for all the technology issues. But there you go. Any questions before we sign out and have a wonderful weekend and all that stuff? Anything at all? Okay. In that case, have a wonderful weekend. Oh, and just a little plug here before we go. I know there's like all 6 of you watching, so I guess everybody else is going to watch later. But I think not everybody on here is even in our class, so we probably have like 4 people that are actually from the class watching. Everybody else is sleeping, which is fine. But a little plug here at the end. Make sure you watch my newest video on how to stay healthy during the coronavirus pandemic. All right, so check it out, watch it, and share it with your friends. Share it with everybody. Share it on social media. It's an important video to help you guys out, or help other people out during this pandemic, as we can see that it's not simply going to go away so easily. Anyway, so see you guys. Have a great weekend, and get some rest and have some fun.